Hello, I'm Tony Svejcar with the Agricultural Research Service and the Eastern Oregon Ag Research Center, and I'm here to present an Ag Minute. Every 5 years, the various research programs within the Agricultural Research Service are evaluated by a panel of outside the agency experts. Much of the ARS program in Burns falls under the Range, Pasture, and Forages National Program. There are 29 locations across the U.S. involved in this program. We are in the process of summarizing our accomplishments over the past 5 years, and I've had a chance to read over much of this material. I'm happy to say that the Burns unit has many accomplishments to list in the national level documents. If you listen to Ag Minutes regularly, you will hear about many of these research projects. For the rest of the week, I'll highlight some accomplishments from other locations and try to illustrate some of the trends that I see in the research programs. This week I'm covering some of the research accomplishments of other ARS locations. In Oklahoma, ARS scientists developed several handheld devices for measuring nitrate levels in forages. Some forages are notorious for accumulating nitrate levels that can be poisonous to livestock. We don't have huge problems with nitrate poisoning in this area, but oat hay is one of the forages on the watch list. With a handheld tester, a person can get immediate results on forage nitrate levels rather than sending samples to a lab and waiting weeks or months for results. We're seeing more and more of these portable testing devices on the market. You've probably all seen the home test for blood sugar and cholesterol levels. Who knows, maybe someday we'll be able to stand by a stack of hay and test relative feed value for a potential buyer. Today I'll be talking about remote sensing, which is the use of photographic images taken from satellites or airplanes, in this case to assess rangelands or pastures. There are many other uses for remote sensing. We've probably all seen examples on the news where the military or weather forecasters use satellite images. There have been many attempts in the past to use remote sensing to assess the condition of rangelands. I always thought this approach had great potential, but in the past there have been technological and cost factors that limited its use. We're beginning to see the practical use of remote sensing tools. ARS scientists in Wyoming have developed techniques for using large-scale aerial photographs to determine rangeland condition. BLM districts in Wyoming and Nevada have been testing this approach for monitoring rangelands. And ARS scientists in Oklahoma have been able to extract real-time estimates of forage quality from remotely sensed images. I think that in the future it will be easier for all land managers to access remotely sensed images on the internet, and there will be more and more tools for extracting information from these images. We probably all know that immediately after a wildfire there is an increased risk of runoff and erosion. Runoff can contribute to downstream flooding, and erosion can cause a loss of on-site productivity. ARS researchers in Boise worked with a large group of cooperators to determine which sites are likely to be most at risk and which erosion mitigation practices are most effective. These researchers then developed a web-based tool that managers can use to make decisions about fire rehabilitation practices. This means that anyone can go to the website, input their specific situation. The tool is now being tested by an interagency team to determine just how well it works under real-world situations. Better decisions about the placement of erosion control efforts could significantly reduce the millions of dollars spent each year to mitigate wildfire impacts. I think there will be more tools of this sort in the future. This is another emerging trend. This week I've been talking about some of the accomplishments of the ARS Range, Pasture, and Forages National Program. I also tried to identify some of the general trends I expect to see into the future, and I have to add the disclaimer that these are my personal opinions. One trend was for an increasing number of portable handheld testing devices. I used the example of the forage nitrate tester. The second trend was for greater use of remotely sensed images in natural resource management. I don't mean that we'll all be looking at satellite photos tomorrow, but I do expect to see a wide variety of uses of this technology in the future. And third, I think there will be wider use of computer and web-based models for natural resource decision-making. This is already occurring in many professions. These tools are becoming more powerful and much easier to use. And yes, if the models are not developed and applied correctly, they will create major problems. They should help us make decisions, not make decisions for us. I'm Tony Svejcar. Thanks for listening.